Hello, Munich. It's a pleasure to meet you. I mean, this place is awesome. Let's agree on this. Anyway, you might have seen my name on this website for code being something like Brazilian Elixir Idol. But don't misunderstand. The idea was that to be an idol, just like those Japanese idols, people that dance and sign, but there's a problem. My dancing and signing lessons didn't start yet. So we'll have to stay with just a presentation on how Erlang handles fault tolerance. I mean, if you have ever played around with Erlang, you might think, it just works. How it handles tolerance? I don't know, it just works. It's true, it just works, but if we can see how it works, if you can understand, we can get the best of it. We can make it be awesome. And you know what else is awesome? Working at Klarna is awesome. And we are hiring any kind of engineer, be it Elixir, Erlang, Ruby developer, anything. Talk with us if you want. Anyway, this presentation is based on 5 main topics. What is an Erlang process? Because what's an Erlang process? If you think, oh, it's some magical being that just works on the pin and doesn't fail, And then we understand about process isolation, why it exists, what it is, why it sounds so weird to say process isolation. And the schedulers, this word is actually a quite bizarre word in Portuguese. It's escalonador. It looks like the escalador word, which is someone that does hiking, and you say, what? Anyway, after we understand what is a scheduler, we can see how it flows. So we can finally understand the point of this whole topic, of this whole presentation, how supervisors react to failure. Okay, that's great. So the first thing we shall see is what is an Erlang process. And to cut all the fun, it can be explained with a single phrase. It's, oh, fuck. It's just a record, a data structure. Yes, it seems that the background failed on this slide. Anyway, we'll stay this way. Leave it as is. That's unfortunate for all of you, and for me particularly. Just a second, I will open the Google Drive one. It should work better. Let me see. I know, I have an idea. Let's throw it on my own Twitter. That way you even have a chance to see my Twitter. That's good. Can I open a browser here? I accept that as an yes. I think this is a browser. Let's see. Sorry, I not really use it to Macintosh. I not really use it to computers at all. Let me see. No, I already somehow got it to work. And ta-da! The internet is amazing. A couple years ago, I would just have to walk around. I would just have to work around with it saying, sorry, my thing is broken, and sorry. Here, found it. Okay, what's the word for presentation in Swedish? I think it's this one. Okay, let's see if now it works. And it works. Now it has colors. Yay! It's a bit blurred, but who cares? The important thing is, a process is just data. It's just a record. To be more precise, it's a record in C, because who doesn't love messing around with C inside Erlang? I don't. I don't want anyone to try this at home. Anyway, what does it have if we simplify? It has a process identifier, who anyone can see as just this data. It says what node it is, what process it is. It's just an unique identifier, so the runtime system can identify processes that are running inside it. It has a mailbox, you know. as we talk about Erlang, I always say, you have mail, like that old AOL software like from the 90s. You got mail, and it stays on the mailbox until you read it. You have the Proxies dictionary, which the people that are more underground on Erlang knows very well, and they should not even know this, because this is not right to use without being needed. It's just an internal key-value storage for the proxies. Doesn't matter. It has a stack. Whoever done, sorry? Whoever might have done a college degree in computer science might know, oh, a stack, it's that thing, blah, 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 blah. I didn't do a college degree in computer science. I just recently found out what this is, and it's hard to explain. It's basically just the function calls and the things that are in there. But it's important to know this, that a stack belongs to a proxies, or better yet, to the memory that, allocated to the proxies, along with the heap. The heap belongs to a proxies. I mean, you have a proxies, they have their own reserved memory part. This is important so you can understand that if a proxies dies, you free memory. It's for free. You don't have to run garbage collection. You don't have to do anything. It's just free. It's magic. And this is important when we start on that very old debate. Should we do tail call recursion? Should we use tabs? Should we use Linux? Whatever. Just kill it. Anyway, let's see what we have learned. That proxies are nothing. They are just data. It's not like a magical being running inside the bean and doing things. No, it's just a small amount of data in the memory. Nothing else, nothing more. And again, a proxy has memory reserved to itself. This is very important. Why? Because when we hear about the magic of functional programming, of how a part of the program can't directly affect another, it's important for us to understand that each proxy is a piece of data that has a region of memory reserved to them that no one else should touch, should read, should write, or whatever. But this is a topic about proxies isolation. So, the first thing you hear when learning Erlang, especially if you are from outside the Erlang world. Personally, this was a bit confusing for me. I started programming with PHP. You cannot win all the times. Anyway, let's say you have two people. English is hard as well. A medical doctor and an accountant. Accountant is the person in a business that keeps track of the money, the expense, and things like that. And then they have things that are called the reports. They have reports to give to the government to say, hey, we are doing things correctly. We are not doing a money laundry right here. But the medical doctor need a few supplies. They want this very new, incredible machine that has hard real-time guarantees that will certainly keep that random person alive. And they say, we gotta buy it. So how do they get these equipment to be bought? Obviously, they steal the documents from the accountant, throw out things that they don't agree, and write over everything, hey, I want this, I want that. And who cares about the accountant? Just let's have all those fun things, right? Wrong, please don't do this. I mean, there are people here from any nationality, but I don't think there is any country that allows you to do things like that without being fired and potentially prosecuted. So don't do that. What should you do on this case? You should write an email. You should fill a form. You should talk with the person, and then the person receives your email, your form, your whatever, and they say, wow, you want this machine, let me see. Okay, we can order it, and then they take care of their business. In the same way, you don't expect an accountant to enter the clinic of the medical doctor and say, You patient, you are very nice. You are having a red dash. That's obviously brain tumor, so go home and enjoy it. At least I hope I never find the neck content to say that to me. Well, let's see what we learned. We learned that proxies can't access other proxies' data. Why? Just as we said, it causes problems. It causes problems to everyone. Let's say we have two proxies doing their things, blah, blah, blah. If you are from object-oriented background, you probably know, oh, just pick the variable, change the value, blah, blah, blah. This causes a lot of troubles, race conditions and whatever. Why? Because everyone wants to change everything in the world. And changing the world is the final objective of everyone. And it's so hard. Anyway, you shouldn't. Instead, through the actorMessageModel, the one that is very well known, thanks to Erlang, we say everyone, or in this case every proxy, is an independent actor that has their responsibilities, their data, whatever. And they communicate through messages to say, hey, I want you to do that. Hey, I need this information, and such. That way, each one takes care of their own lives, and they just, this is how we do in real life. You don't go around robbing someone's cell phone and purchasing things. You don't go taking away their keys and entering their homes. At least I hope you don't do that. Anyway, since everything is isolated, parallelization is easy. We'll cover this topic better later. And finally, it's very rude to write on your friend's journal without their permission. Remember this. This is a lesson for life. So, I talked about the scheduler, the thing that in Portuguese has a very strange word. So let's understand what is it besides a strange word in Portuguese. A scheduler. Oh no, we don't have a lot of contrast, but I think you can see I have a laser here somewhere. Let me see. It's here, yay! We have this gray box here. It's what I call a scheduler. What it is, it's nothing. It doesn't matter. A scheduler is just an abstraction. A scheduler is a process that picks a lot of things to do and ensures that they are done in an ordered way, such that everything can eventually be done. So, when you are running your programs in Windows, Linux, Macintosh, Solaris, or other sick things, you can be sure that a scheduler is ensuring all your programs are running because I don't know how many people, I think basically everyone here remember that not long ago we only had a single core in the computer. So how could we run a lot of things at the same time? Move the mouse, watch some nice video on Flash player. I mean, seriously, Flash. Well, there's not much we can do. Access our CUT, talk with on ECKey, receive emails through oh, you got mail. It's nice. Things seems to be working at the same time, but technically, a scheduler is behind this, picking all those very small tasks and executing them in an ordered fashion to ensure all them are executed. And so it makes it seem that like everything is happening at the same time. But technically, it's ordered like this. There is an order here. And we're going to take one piece of job. And we're going to do it. Done. And then we take the next piece of job. And boom, we do it. And that's just what a scheduler does. It picks the job, the work that you have defined and does it. What is on work here? Each of these is a process. So when you say spawn hello world, it appears on this task. It might be this wallet. Remember, don't take someone else's wallet. Anyway, it might be this wallet on this graph. It's just a process that the scheduler takes and the scheduler eventually executes it. It's their responsibility. Anyway, I even lost my part. A scheduler is a process that arranges and executes work in an ordered fashion. That's just it, no more, no less. Jobs are independent, and the scheduler is responsible for ensuring they get done. And this part is important, and don't block. Because let's think about this. We might have had this a long time ago when you try to run a program and then, nothing works anymore. Why? Because someone blocked the scheduler and it can't do its job, so nothing can run until that finishes. So Erlang has what we call as preemptive scheduler. It's a scheduler that not only executes jobs, but it has complete control to start and stop jobs. So let's see how this does. Let's get it to another level. Let's see the scheduling flow, because 1 is good, but 2 is better. So now we have dual core. It's 2 schedulers in 1 computer. We are in the future. This was considered a supercomputer not long ago. It's what they say, right? So everyone has their work to do. Everyone does the work. And everything is fine because things are just working. Is this the future? Yes, it is. But then, wait. The work here has been done, but the work here is still executing. Oh no, is this a while true? Print hello world? It looks like such. So does that mean that our program is going to suddenly freeze because we were not careful enough and we left a bad loop? On Erlang, that's not true. The scheduler, since it is a preemptive scheduler, it says, hey, you are working too much, but I have more work to do, so let's be friends. You go, sit there, yes, there. In the end of the queue, I did not put, I just made it grayer, but it's now going to go on the next loop of the scheduler. So it is the lowest priority right now. Its work will continue, but not now. You just wait because I have a lot of other proxies to resolve. And then it goes, it executes the next. And do you remember this? Our friend, a cat. Whoever has a cat understands that cats like to break things. And the process suddenly fails. Process die like people all the time. It just happens. And here, it has happened. But what can we expect now? Will this break our scheduler? Unbelievable! It is still working. Why? Because the Erlang scheduler, it has control over everything. It's a preemptive scheduler that just encapsulates the execution of processes, because processes are just data. We have pointers to what should be done. We have data that should be used, blah, 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 yada, yada. And it just does that if the process suddenly fails. Oh, no! Unexpected new pointer exception. What do we do? Just fuck it. Throw it away. Let's go forward. And that's what happens in Erlang. That's why, even if you wrote a very good RAID, very not well designed software in Erlang in the late 80s, it might still work, even if it breaks, because it can recover. This is the so-called fault tolerance. If something breaks, just let it break and go forward with life. It doesn't affect anything else, because memory is isolated. Memory is everywhere, but everyone has their own responsibilities. I can't get shot and shot everyone else. This is not correct. If I die by myself. Fortunately, I'm not dead yet. So, with all that, we know that since Erlang isolates everything in very small pieces of work, if something happens to not be done, happens to fail, happens to explode, happens to die, happens to be in the amidst a nuclear war where all your servers are turned down. Wait, let's not cover this topic because we are talking just about schedulers. It just works. This is the just works. Things continue. Like life. Sometimes people die with just, I have to go on with life. But now we have to go on without this scheduler. Let's forget that this one exists. Let's focus on the scheduler 1. We have now the process compact disk. It has been quite some time since I last saw compact discs being sold, now that we have Spotify, Tidal, and such. But anyway, let's say that this compact disc process is waiting for a message that's not on their mailbox. What do you think it happened? Do you think it will block the scheduler and just, no, nobody moves until I receive my message? No, it's nothing like that. We just throw it out outside of the scheduling flow into a definite area, because remember again, processes are just data. They are nothing else. So they can exist and make no difference. They are just there. They are just blocks of data. 101, 101 binaries, things, useless things that just stay there until they are called. Okay, so it doesn't affect the scheduler flow anymore until it receives the message. So you can see that we've learned on this very long conversation about how schedulers work together, that the VM has control over everything. It can handle errors in a higher level. That is, things broke, the VM knows, the VM takes care and isolates it. There is no plague in Erlang. Erlang is the plague itself. Sleeping processes don't affect scheduling. This is a very common question when you get to understand the scheduler. Okay, I have a gazillion of processes that are just sleeping, taking care of something else. Will this make my program slower? No, it won't. Those processes are just memory that is allocated and keeps waiting. So let's say you have 1,000 of supervisors. Supervisors are just programs, just processes that monitor other processes. So they are just there waiting for a message, nothing else. So they are here, just waiting. They are not being scheduled. They are just waiting for a message saying, hey, I'm dead, please revive me. The VM has a scheduler that allows it to postpone processes that are taking too long. Do you remember our friend, the infinity process? It was taking too long, so we postponed it so we can do everything and then go back to it. What does that mean? It means that if you are on a server that has lots of requests, and one of them, for some reason, is very CPU intensive, it will not make everyone wait until it's done. Let's say it takes like 1 minute of computations, because why not? It doesn't mean that everyone has to wait 1 minute to get their response. It means that it will be executed until it has worked too much, it's postponed, then everything is solved, and then we go back to it. If it is not done yet, we do the same until we are done. So what does that mean? That we have what is called reduced performance, because what we do, we ensure that everything is resolved, even if it means diminished performance on those parts. Things might go slower, but they will work. That's what you can take as granted. My mouth is dry. As processes are isolated, we can improve parallelization by adding more schedulers. As we've seen here, we've before had only a single scheduler, so we were doing only a process per time. Now that we have 2 cores, it's the amazing Intel Core 2 Duo. We can do 2 things at the same time, and now it's really at the same time. It's not just a faking. So by adding more schedulers, in this case, adding more cores, we can do more things with Erlang at the same time, because since processes are isolated, we can execute them in anywhere. And technically, anywhere can also include other machines. And that's amazing. So now we go to the very important part, how supervisors react to failures. Because Erlang is all built on the OTP platform, that's how we like to call it. But in fact, the OTP is nothing more than a set of things that you have to follow to properly take the most from the Erlang runtime. In this case, it's the supervisor tree. Everyone loves the supervisor tree. The supervisor tree is something like this. We have an application that has proxies that represents data being held, like a database connection, has proxies like an ad provider, I don't know. Those are just examples. It can run a lot of things. And it means that we have dependencies here and such, blah, blah, yada, yada. This talk is not about this, unfortunately. But it's about something. Let's say that our real nice Phoenix framework proxies here has also a child that is a chat. And let's say, well, if the chat explodes, does it mean that my whole application is going to die and explode and become just ashes? No. A bug happened, things explode, things break. We cut it away, and then we restart it. Do you remember that processes are just data? What does it mean? Let's go to the first slide. Just data. The process has gone into a bad state. What do we do when the state gets too corrupted? We kill it with fire. So everything here is lost. It does not have more its process identifier because we killed the process. It doesn't not have its messages anymore because we killed the process. It does not occupy the memory it was occupying because we killed it. And then what do? We get them back onto a state that we know it's safe. It's the state of the very beginning. When we just signed the Constitution, we now have a free state and things like that. I don't know, it gets very good. We have everything working, everything is so nice, and your program got back into its feet in a very smooth way. And you know what else is smooth? Working at Klarna is smooth. So you should come talk with us. Seriously, we are hiring from all the world to Klarna to work with probably the biggest application in Erlang in the whole world. Thank you, everybody. So, I can see from your face, we have a lot of questions. Even if you don't want to ask them, we have questions like, okay, why do we have a pooping balloon? Or where do I sign for Klarna? Things like that. It's your time now to ask those questions. So, I want to see your arms up. And sorry, I forgot my glasses back at Sweden, so I can't see those arms, so it have to be very far. Reach me, let's go. Yeah.
One of the best presentations I've ever seen.
Thank you. I'm very happy with that. Thank you very much. I'm very happy that you liked this presentation. Fortunately, it's being recorded, so you can see it anytime that you want to have some inspiration. So, next question. Where's the arms? Where's the arms? Yeah.
How did you learn all this? Like, what's your resources?
The internet. No, seriously. The Erlang project, since it has been open sourced because it was originally by Ericsson, blah, 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 things that Jane has already talked, it has evolved a lot, but some parts are not really well documented, so you can only find out by reading the source or asking at Reddit. There were some good questions at Reddit on how Proxys really works, and I think it was Robert Virding that responded to those comments, explaining the best he can. So you can find a few blog posts about this. There was one very good recently that was from Fred Hebert when he still worked at Heroku about the memory allocation. I'll try to get into my... Those slides are going to be published. I think the link will be provided. So on the observations, I put the links for those resources, so you can get a grasp more deeper on that. But it's basically, you have to read the source. You have to fight with that C code from the 80s, and let's see if you end victorious. But that's it. Anything else? Let me see who is asking a question because I'm not hearing very well. You? Yeah?
Any chance of working for us?
Are you Klarna? Well,
Probably not.
technically I cannot say anything about work right now because I am at work right now. Any more questions? No? Thank you very much, everyone.